In Chapter 4, you are introduced to quantitative data and the type of displays that you can use and describing the data. So you should be familiar with the histogram, the dot plot, and the stem and leaf plot. You are also told how to describe the data. Now remember, whenever you are given a data set, the first thing you ask yourself is what type of data? Is it categorical or is it quantitative? And one hint to determine if it's quantitative is that it will have units and it is continuous. In this lesson, I would like to show how to describe the data. So there are three features you should always describe: the shape, the spread, and the center. So shape, center, spread. When addressing the shape, you are determining, is it symmetric? Now if it's symmetric, you should be able to draw a line through the data and fold the data, the graph, on this line, and the edges should line up fairly evenly. So this graph would look fairly symmetric, and this graph is also a representation of a symmetric graph. Perhaps the data is skewed. If skewed, the data will have a tail to one end. So this is an extreme example of skewed to the left. Notice my tail is to the left, and I have a bunch of data values that are lower numbers. Or perhaps you have data that is skewed to the right. So skewed to the right will have a tail that goes off to the right, and we have a bunch of large data values, assuming that we have a typical number line where these are my low values and these are my high values. You also want to determine if the graph is uniform, unimodal, bimodal, or multimodal. So a uniform graph will be a graph where the data values, there's the same frequency for each set of data values. So this is fairly rectangular. Unimodal means that we have one hump. So this is an example of unimodal. A mode would be the most frequently occurring value, and perhaps it is bimodal, so we would have two humps. So this would be a clear example of bimodal. You could also have many modes. And center would be the typical value. And we will be discussing various values for the center, primarily the median and the mean. So if I were looking at this data set, my center would be approximately in the middle. For this data set, my center would be at the mode, the most frequently occurring value. And for this data set, my center would be somewhere right between the two modes. Notice this data set here does represent a symmetric distribution. You also want to describe the spread, how much the data value varies, and we usually use the range or the interquartile range, two terms that you should be familiar with at this time. So I wanted to look at an actual data set. So I went online and I searched for data values, some information about the weather in Concord, New Hampshire during the month of August. So notice that we have the maximum temperature, and I assume this is the high temperature, maximum temperature in Concord, the minimum temperature, the average, and various other information. Right now, I would just like to focus on the maximum temperature in Concord, New Hampshire for August of 2013. So you should be getting familiar with using your TI-83 or your TI-84. So given a set of data, first thing you'll want to do is turn on your calculator, and you'll want to enter the data into the calculator. So in order to enter the data, you need to push this button called Stat. So I'll select Stat, and I want to edit, meaning I want to enter data. So I'll select number 1, and I can do that by pushing number 1 or hitting enter. And notice I've already entered some of the data. So if I go down this list, I've entered 10. Notice it says 10 down here. My 10th data value is 81. And if I look over here, my 10th day of August, the high temperature was 81. So I still have to enter the data for August 11th and 12th. So I need to enter 79 and 81. Now that the data is entered, I can do a variety of things. And one thing that's pretty cool is I can order the data from high to low. In order to order the data from high to low, I need to select Stat once again. So I'm just going to push the Stat button. And notice I have Sort A, Sort Ascending, or Sort D, Sort Descending. So I'm going to select number 2, Sort Ascending. And at this point, the calculator is asking me, what list would you like sorted? Notice your list names are in yellow above the number keys. So list 1, list 2, list 3. Also, yellow means I must push the second button first. So I push second, and then number 1 for L1. Always smart to close the parentheses. I'll hit enter. The calculator says done. I go back to my list, and notice that the data is now in order. So I can quickly see that my data has a range, has a spread from 73 down to 84. So if I want to determine the range, I would just do 84 minus 73 in order to get the value of 11, and that's the range. I now might want to create a dot plot of this data. So to create the dot plot, I'm going to take this data, and this is pretty cool. I can take this data and I can copy it, and then I can put it into a Fathom file. So I've already done this. I copied the data and I put it into Fathom, and I'll teach you this more. I'll go over this in more detail at a later time. But I can create a dot plot of this Fathom file has the same data that was presented on the website. So notice I have the max and the min and the average for the first 12 days in Concord, New Hampshire. So in order to create a display, I'm going to go up to Graph, select Graph, notice the hand pulling the graph down, and release. I now want to put my variable maximum temperature on the graph. So I select Graph, notice once again I have a hand, I select max, and I drag the max, and I like to put my variable on the x-axis, and I release. Notice Fathom automatically created a graph for me, started the graph at a low temperature of 72 degrees Fahrenheit and went up to 86. I can actually control those. Gave the graph, the axis, the label name max, since that's the name of the variable. I probably would like to add maximum temperature in Fahrenheit. Always include the units when possible. And each dot represents one case. So 73 degrees represents the temperature on August 9th. And 84 degrees represents the temperature on August 8th. We can see from the dot plot that we have a mode. There were 3 days that had a temperature of 81 degrees. And since this is the most frequently occurring temperature, this is considered the mode. Fathom lets me easily convert this graph to a histogram. I go up to this menu where I have dot plot and I open it up, and notice we have a number of options, and I would like histogram. With Fathom, we will primarily be using dot plots and histograms. And now notice on the y-axis, I have the frequency or the count. How many days actually had a maximum temperature of the indicated temperature. So only one day had a maximum of 73 degrees. We can see 2 days had a maximum of 77 days. And once again, our mode is showing up. 3 days had a maximum temperature of 81 degrees. So if we were asked to describe this distribution, remember the 3 features that you should discuss: shape, center, and spread. So the shape of this graph is unimodal. We have one mode, and I would say that it is skewed to the right, skewed to the left. We have a number of values falling at the low temperatures. And we would also need to describe the center. The typical temperature during these 12 days in Concord, New Hampshire, the typical maximum temperature, I would say, is around 79. Right now, I'm just estimating that from the graph. And we have a spread from 73 degrees up to 84 degrees. Therefore, our range would be 84 minus 73. So we have a range of 11 degrees Fahrenheit. So during the first 12 days of August 2013 in Concord, New Hampshire, the distribution of our temperature is unimodal and skewed to the left, with a typical maximum temperature of around 79 degrees and a range of about 11 degrees. So there's a little bit of variability, but not a lot. I personally would prefer these lower temperatures. We also should discuss if there are any unusual features or outliers. And I would be a little concerned about these temperatures down here, the 73 degrees. I would say 73 degrees represents a potential outlier. 73 degrees is a potential outlier. And we will learn how to determine if this is an actual outlier later on. So I hope this helps, and I hope this helps you understand the shape of the graph a little bit better.